All right, welcome back, geometry. This is page 2 of the chapter 10 test review. So this will take us through number 7 through number 13. The next video I will post will be the last couple problems, 14 through 19. So we are going to jump right in with number 7 here. Number 7, find the area of the regular hexagon. Round your answers to the nearest tenth. And they give us a hint. We want to use special right triangles or trigonometry to help us. Let's certainly do that. So once again, the area for a regular polygon is half times the apothem times the perimeter. Perimeter is pretty easy to find. The perimeter, we're going to use 16 times 6. If you want to include the actual value for that, you certainly can. What is that? That's 36 plus 60, which is 96. So that should be 96. Maybe I'll write that down here. Now we got to find the apothem. In order to do that, I'm going to do the following. I apologize for my triangles. Those are supposed to be all triangles. So I want to take, maybe I'll show it over here. 360 divided by 6. Each of those angles is 60 degrees. So this angle here is 60. I want half of that. That'll give me my apothem angle. So 60 divided by 2, 30. So you got 30 degrees. So right up here, maybe I'll do this triangle here. I'll try to highlight it for you quick. I do not claim to be an artist in any way, shape, or form. So that angle there is 30, which makes this angle down here 60. We have a 30, 60, 90 right triangle. You can use special right triangles here. So we need to find this length here now. Good news is it's half of 16. That's 8. Now, if you remember from special right triangles, if our short side is 8, our height is that short side root 3. So I'm going to call this side A for apothem, and A is 8 root 3. Again, I don't need to show any algebra there because it's just a special right triangle. So there's our apothem. We've got our perimeter. Multiply everything by a half. And there we go. So take square root of 3, convert it into a decimal. You know that. So multiply everything together, and you should get a final area of right around 665.1. We don't have units, so I'm going to write units squared. So that's my answer for number 7. 665.1 square units. Number 8. The sides of two similar trapezoids are in a ratio of 1 to 3. The area of the smaller trapezoid is 12 inches squared. We want to find the area of the larger trapezoid. So we have a side ratio of 1 to 3. If I want to do the area ratio, which I'm eventually going to, I need to square both the 1 and the 3. So that means the area ratio would be 1 over 9. Now I need to set up a proportion. Area of the smaller trapezoid is 12. We don't know that. Larger area. Here it's a matter of cross multiplying. Super easy cross multiplication. 12 times 9 is 108. Maybe I'll highlight the cross multiplication. So x is equal to 108 inches squared. There we go. Number 8 done. Number 9, here we go. The areas of two similar triangles are 120 centimeters and 270 centimeters squared. What is the ratio of their parameters? So area ratio Here it's similar to the last problem, just a little bit different. So 120 over 270. I want to simplify. To an area ratio of 4 to 9. I want to take the square root of both sides, and that gets me 2 to 3. So that's the perimeter ratio. So that's 2/3. If I want to write it as a ratio, I want to say 2 to 3. That's the one I want. I don't want the fraction. Now, number 10, number 11, and number 12. There is more than one answer. I'm just going to list a few. Number 10, name a minor arc. And I'm going to write EX for example. So examples, we have IH. That could be one. Another potential answer that we could have is GF. Another answer we could have is HF. And I'm going to stop there, but know that there are more. Name a semicircle. Again, there is more than one. I could say IEF. That's one. It's supposed to be an E. There we go. And we have HGE. That's another one. And there are more. I'm just going to stop with 2. Here I want to name a major arc for number 12. Again, more than one. I could say IHE, or I could say GEI. And I'm going to stop there. There are more than one answers, though. Last one for this video, number 13. Find the measure of the arc indicated. We want to find EF, this guy here. Here we have a semicircle. Semicircles have a degree measure of 180. So take 180 minus 120. That'll get you EF, which is 60 degrees. So that is page 2 done. Stay tuned for page 3, which is 14 through 18, and I'm going to throw the last one on there, number 19 as well. So stay tuned. We'll see you in a bit.